Hello students, and welcome to our lesson on solving proportions. So to get started, we need to know what is a proportion. So a proportion is an equation with exactly one fraction on each side of the equal sign. So in this lesson, we're going to have a whole bunch of situations where we have a fraction is equal to another fraction. We have a very special property, and that is that cross products of proportions must be equal to each other. So the word cross product or the phrase cross product means that when you multiply diagonally, so the top or the numerator of one fraction times the denominator of the other fraction, and vice versa, we get a new equation that's equal to the original equation. So in the first example here, I'm just going to show you the cross product and set them equal. In the second example, I'll show you why using a couple extra steps. And in the third one, we'll go back to just setting them equal to each other. So some people, by the way, call this the butterfly method. So if you've heard it described that way, perfectly acceptable to use that. However, I will be referring to them as cross products. So example one, what we want to do to find the cross product is multiply the bottom of one fraction times the top of the other fraction. So we're going to do 2 times 6, and then we're going to do 3 times 4. When I multiply 2 times 6, I get 12. And when I multiply 3 times 4, I get 12. And so we started with 2/3 equals 4/6, which based on our knowledge of fractions, we should know to be true. Those are equivalent fractions, so those are equal. And the fact that we had two fractions that are equivalent set equal to each other meant that we were not doomed from the start. We were going to be able to make something good out of this. And so it makes sense that we get 12 is equal to 12. If these fractions were not equivalent to each other, then the cross products would not have been equal because we would have had inequality from the start. But it is true that when we have equality, one fraction equals another fraction. If you multiply across, then you get a new equation where the cross products are equal to each other. So now let's see why in 2 steps. So for the second one, if I wanted to isolate or get rid of the denominators here, what I would do is multiply the denominator that's on the left on both sides. So if I multiply times 2 on both sides, that is going to get rid of this 2 on the left. And so I will get 1 is equal to, on the right side, I would do 5 times 2, which is 10 over 10. Now, we're not trying to simplify the fractions right now. We're just trying to show that cross products are equal. So even though 10 over 10 is 1, we're not going to reduce that. Instead, we're going to multiply both sides by 10 to get rid of that denominator. So when I do that, we can see the 10s on the right cancel, and I'm left with 10 times 1 is 10, and on the right side, I just have 10. So if we don't want to do cross products, what we can do is eliminate the denominators by multiplying both sides of the equation by whatever the denominator is. But because the cancelization that happens, aka 2 cancels 2 and 10 cancels 10, instead of doing those two steps, we can just go straight to 1 times 10 gives us the 10 on the left, and then 2 times 5 gives us the 10 on the right. So instead of getting rid of denominators the old-fashioned way, when you have a proportion, you can just multiply across. So now we'll see another example where we just multiply across. 2 times 72 in this next equation will give us 144. And if we multiply across the other diagonal, 9 times 16 is also going to give us 144. So we always have that in proportions, cross products are equal. Generally speaking, though, we're not just going to say that two fractions are equal to each other. We're going to have a variable somewhere in there that we're going to solve for. So for number 1 here, we have steps for solving a proportion. We are going to cross multiply to eliminate the fractions, meaning we're going to do the steps we did above to get rid of fractions and just have something equals something where there's no more denominators. And then we're going to solve the equation that remains. So after we've done the cross multiplication, then we will solve whatever we get left. So for number 1, x minus 1 over 6x equals 4 over 9. We have a fraction equal to another fraction. That means we are in a proportion. So we can go ahead and cross multiply x minus 1 times 9. Be careful when you have a binomial. We have to make sure that we distribute that 9 to both things inside. And on the other diagonal, we have 6x times 4, which is just 24x. So I'll do that one right away. So now we're going to distribute the x minus 1 times 9 to get 9x minus 9. So we now have 9x minus 9 equals 24x. And we can go ahead and solve this like any other equation, where if I move the 9x to the right, we're going to have negative 9. If I subtract the 9x over, equals 15x. And then if I divide both sides by 15, negative 9 over 15 is going to be equal to x. And so we just want to make sure that we reduce fractions now. 9 and 15 are both divisible by 3, so we can reduce this fraction to be negative 3 over 5 is equal to x. And alternatively, this is also equivalent, so we can say or x equals negative 0.6, which is the decimal form. Now I want to clarify one thing real quick. When I say reduce fractions, the reason I say reduce is because we are actually reducing the number of terms or the number of factors that are in the numerator and denominator. So as a quick little aside, this fraction right here, negative 9 over 15, negative 9 is really 3 times 3, negative 3 times 3, I should say, and 15 is really 5 times 3. So if we write this fraction using prime factorization, we factor the top and bottom, then we can reduce the number of factors. So the 3 and the 3 are the same, so they're going to divide each other out to give us 1. And this will just be equal to negative 3 over 5, which is what we had down below. But when I say reduce fractions, the reason I say reduce is we are reducing the number of factors in the numerator and denominator. All right, number 2, we have 5/3 equals x plus 3 over x minus 3. Again, we are going to multiply across the top to the bottom. So we're going to get 5 times x minus 3. And we will multiply from the bottom of the first one to the top of the second one. So 3 times x plus 3. Notice I'm using those parentheses because I have to distribute in both these places. On the left side, when I distribute the 5 to the x minus 3, I get 5x minus 15. And on the right side, when I distribute the 3 to the x plus 3, I get 3x plus 9. Now we have a two-step equation. We're going to collect the x's on the left and the constants on the right. So if I subtract 3x from both sides, I get 2x minus 15 is equal to 9 because I move those 3x's over by subtracting. Then if I add 15 to both sides, I get that 2x is equal to 24. 9 plus 15 gives me 24. And now I can go ahead and divide both sides by 2 to get that x is equal to 12. So not too bad. We have that cross products are equal to each other, and then we solve the equation that comes out of that cross multiplication. Okay, number 3, same steps. We're going to take the 3 in the denominator and multiply by that x minus 5 on top. So 3 times x minus 5. Then we're going to take the 2x minus 5 and multiply it by the 7. So we're going to have a 7 multiplied by a 2x minus 5. We go ahead and distribute. So 3 times x minus 5 is 3x minus 15. And 7 times 2x minus 5 is 14x minus 35. We are now left with a two-step equation where we can collect the x's on one side and the constants on the other. So I'm going to go ahead and subtract 3x from both sides to get 11x on the right. So I'm going to have negative 15 equals 11x minus 35. And the reason I moved the 3x's to the right instead of the 14x's to the left is because I prefer to keep the variable term positive. If I would have subtracted 14x from both sides, I'll get the same answer in the end. I'll just have an extra negative sign floating around that I don't want to deal with. So instead, I move the 3x's to the right. All right, now we need to isolate the variable by adding 35 to both sides. So 15 plus 35 is going to give us 20 equals 11x. Divide both sides by 11, and we get that x is equal to 20 over 11. Now, we could turn this one into a decimal, but it's going to be a repeating decimal when we do it. So I would argue that it is better to leave it as a fraction. If you do want to turn it into a decimal though, we can go ahead and pull out a calculator and type in 20 over 11. And notice we get 1.81818181. So we can write that answer as 1.81 with a bar over the 81 is equal to x, where that bar just signifies that the 81 continues to repeat itself. All right, now there's a you try problem. Please pause the video, give it an attempt. Hopefully you paused. And so now coming back, we are going to multiply x minus 4 times 5 to get 5 times x minus 4. And then on the other side, we're going to multiply 3 times x plus 1. So 3 parentheses x plus 1. When we distribute, we're going to get 5x minus 20 on the left. And on the right side, when we distribute, we're going to get 3x plus 3. So now we have a two-step equation. I'm going to go ahead and subtract 3x from both sides to get that 2x minus 20 is equal to 3. I'm going to add 20 to both sides to get that 2x is equal to 23, and then divide by 2 to get that x is 23 over 2. Now, 23 over 2 is, in my opinion, the best answer, but if you prefer a decimal, you could also say that x is 11.5, and that is just as good. I will just want to clarify, though, that if your decimal does not terminate, meaning it doesn't stop, it keeps going like it did in number 3, I strongly prefer you leave your answer as a fraction because writing the bar over the 8-1 sometimes is a little bit hard to read, gets lost in translation, whereas 20 over 11, very clear and concise. If your decimal does terminate though, like it did in number 1 and the you try one, so we got either negative 0.6 or 11.5, there's no rounding happening, then you're welcome to write your answer as a decimal. All right, so now let's do some applications that work with these. So we want to apply the process of solving proportions to some word problems here. As always, when we are introduced with word problems, we want to make sure that we read the problem and mark the text up in a way that helps us set up the equation that we're going to try to solve. We want to define the variable that we're going to be solving for, because if you don't know what you're solving for, it's kind of hard to move in the right direction. Okay, then we want to organize the information we're given in a way that allows us to solve. So this might mean draw a picture, it might mean make a table. It might not really mean anything. The information might be nice and clear to us. But whenever you have things floating around, it's always good to try to put them together in a way where you actually know what you're looking at. And then we're going to use the organized information to write an equation that models the scenario. Okay, so remember, we want to model or represent the scenario using mathematics, using an equation. That way we have something we can solve. And at the end, we will then solve that equation, and we're going to make sure that our answer actually makes sense. By makes sense, I just mean reread your answer, see if it fits the criteria the word problem was describing. Sometimes you might get a negative answer when a negative number is not even possible, such as if you're solving for the weight of an animal and you get a negative number, well, weight can't be negative, so that would not make sense. So just always make sure at the end that we're checking that our answers make sense. All right, number 4. A nurse needs to dilute a medication. She mixes the medication with water to create a 1 to 5 concentration of medicine to water. That means that there is 5 times as much water as there is medicine. How much water was added if the total mixture is 12 milliliters? So we need to turn this into a proportion somehow. So we know that the total amount added, or the total amount of the mixture, is 12 milliliters, but we want to solve for how much water that actually is. So how much water was added, we'll call that W. So now we have that the ratio of medicine to water is 1 to 5. Okay, so we're going to make a little note here. If the ratio of medicine to water is 1 to 5, that means that the medicine makes up 1/6 of the water. So if the ratio, ooh, I put ration, if the ratio of medicine to water is 1 to 5, then medicine is 1/6 of the solution. Okay, so now how do I know that medicine is 1/6 of the solution? Well, if you have 1 milliliter of water and 5 milliliters, or sorry, 1 milliliter of medicine and 5 milliliters of water, together that's 6 milliliters of solution. So the way we find out what ratio or what proportion we have is that however many pieces are in the ratio, so in this case 1 to 5, you put that number on top, and then on bottom you add together 1 plus 5 gives us 6 total pieces. So of the 6 pieces, medicine is one of them. So now we got to turn this around. We want to know how much water is added. So if medicine is 1/6 of the solution, okay, then water is 5/6 of the solution. Because if 1/6 of it is medicine and the only other thing in it is water, then 5/6 of the solution is water. And notice the same thing I just told you applies. If we want to know what the 5 represents, the 5 is how much water, that goes on top. And then the denominator is the two pieces together give us the 6 on bottom. So if the ratio is 1 to 5 medicine to water, the medicine is 1/6 of the solution, and the water is 5/6 of the solution. So now we are going to use this to set up a proportion. We have that water is 5/6 of the solution. And we have that the solution has a total amount of 12 milliliters. So in the denominator right here of my fraction, we have the total amount, and in the numerator, we have water. So if water is 5 and the total is 6, but now our new total is 12, okay, so 12 is the new total, then what goes on top of the 12 is the amount of water it takes to create a 12 milliliter mixture. So I'm going to put our variable W on top, where that W represents the water. So in the end, this actually becomes a very simple proportion to set up. 5/6 is equal to W over 12. And then we just have to figure out what W should be. But in order to get to that proportion, we have to understand how the ratio of 1 part to 5 parts turns into a fraction involving the total amount of the mixture being 12. So it's always however many parts you have, that goes on top, and you add together the total number of parts and put that on bottom. So this is water to total. And then since our new total is 12, we put water on top and we can solve for it. Now we can go ahead and actually solve. If 5/6 is equal to W over 12, we're going to multiply across. 5 times 12 is 60. And across the other way, 6 times W is 6W. So we get 60 equals 6W, divide by 6, and we get that W is equal to 10. So that means that the mixture is 10 milliliters of water. And if the total mixture is 12 milliliters and 10 of it is water, that means there was 2 milliliters of medicine. So in this scenario, the nurse needed to dilute 2 milliliters of medication by using 10 milliliters of water to create a total of a 12 milliliter solution. All right, number 5. A nurse has successfully placed an IV on the first try for 21 out of 30 patients. How many consecutive IVs must be placed to raise the average to an 82%? All right, so the nurse has so far placed an IV correctly in 21 out of 30 patients. So we have a ratio there that it's 21 successes over 30 attempts. So we have 21 over 30 is our successes to our attempts. And notice that if we divide 21 by 30, we get 0.7, which is where the 70% comes from. Okay, 21 out of 30 is a 70% success. So now we want to figure out how to raise this to be an average of 82%. So right now we're at 21 over 30, and it's asking us if we have consecutive successful IV places, how many do we have to do to get to 82%? Well, we have to think about how do we modify this fraction, 21 over 30. So if you place one successful IV, so if one success happens, so your very next attempt is successful, then you would have 22 successes out of 31 attempts, where notice I added one to both the top and the bottom. So then if I'm successful again, so if one more success, then we would now have 23 successes out of 32 attempts, where again, we have to add one to both the number of successes and the number of attempts because we can't be successful without having an additional attempt. So the question then is, how do I represent getting consecutive successes? Well, if every time I'm successful in a row, I add one to both the top and the bottom, then we can say that 21 plus x over 30 plus x represents our new average when we have successful attempts. So every time I increase x by 1, I add 1 to the number of successes, and I also add 1 to the number of attempts. So 21 plus x over 30 plus x is going to represent our new average when we do consecutive IVs. Okay, so the fact that we're doing consecutive IVs is what tells me to add x to both the top and the bottom. So consecutive successes. So now the question is, when will this function we have, 21 plus x, 21 plus x over 30 plus x, when will this be 82%? So 82%, we have to think, what is 82%? Well, 82% means 82 out of 100. So if I want to gain 82%, I need to set this equal to 82 over 100, where now I have my proportion that I can solve. I have that 21 plus x over 30 plus x is equal to 82 over 100. So I want to find out how many successes do I need to have in a row in order to get to 82%. All right, so now we can go ahead and solve this thing. So we have 21 plus x equals 82 over 100. If I multiply, I'm going to get from the top 21 plus x times 100 is going to be equal to the other direction of the cross multiplication, 82 times 30 plus x. If I distribute the 100, I get 2100 plus 100x is equal to 82 times 30 is 246 with a 0 on it. The way I did that, by the way, is I just multiplied 82 times 3 to get 246, but then tacked a 0 on. And that's plus 82x, because I distribute the 82 to both places. Yeah, I'm going to move this one up here so I can keep working. So we have 2100 plus 100x equals 2460 plus 82x. I want to now solve this two-step equation. So I'm going to get all the x's to one side and all the constants to the other side. If I subtract 82x from both sides, I will get 18x on the left. So I have 2100 plus 18x equals 2460. If I then subtract the 2100, I get 18x equals 360 because 2460 minus 2100. And then now we want to divide both sides by 18. When we divide by 18, we get x equals 20. So what that means is that the nurse needs to place 20 successful IVs in a row or consecutively in order to raise the average to be 82%. So we need 20 consecutive IVs placed. And if the nurse can do 20 IVs in a row, the new average of successes will be 82%. All right, last one is a you try, so please go ahead and pause the video if you haven't done so to practice already. All right, it says a dosage chart recommends 5 milligrams of a drug per 2 kilograms of body weight. How much did the patient weigh if they were correctly given 125 milligrams of the drug? So we have one ratio of 5 milligrams of drug to 2 kilograms of body weight. So 5 drug over 2 body weight is our ratio there. 5 milligrams of the drug corresponds to 2 kilograms of body weight. And we want to find out how much the patient needed to weigh if they were correctly given 125 milligrams of the drug. So I can set up an equivalent fraction on the other side where I know how much of the drug I was given, 125 milligrams. So 125 drug over, and we're trying to find out how much did the patient weigh. So this is our X variable. So we're trying to find out how many kilograms did the patient weigh if they were correctly given 125 milligrams of the drug. So our ratio is milligrams of drug on top, kilograms of body weight on bottom. So we have milligrams of the drug over kilograms of body weight equals milligrams of the drug over kilograms of body weight. And so we can go ahead and now find the cross product. If we do 5 multiplied across times x, we get 5x. And we're going to set this equal to 2 multiplied across times 125. So 2 times 125 is 250. So we have 5x equals 250. If we divide by 5, we're going to get that x is equal to 50. And so that would mean that the patient weighed 50 kilograms. So now we can go ahead and double check that this answer actually makes sense. If you're supposed to be given 5 milligrams of the drug for every 2 kilograms of body weight, and you weigh 50 kilograms, the way you would decide how much of the drug you need is you divide 50 kilograms by 2 to get that you weigh a ratio of 50 over 2, so 25 units. Then you multiply that 25 by 5 because you get 5 milligrams for every 2 kilograms. 5 times 25 gives you that 125 milligrams of the drug you were given. So we can set up a proportion, we can cross multiply and solve, and then we can actually put this to use. I would say this you try one is probably the most important problem because when you are doing dosages, sometimes you are going to have to break out the math. There might not just be a nice convenient chart given to you. You might need to actually calculate, hey, based on the amount this person weighs, how much of this drug should I administer to them? So important problem, important math to be able to do. Hopefully you enjoyed the video, and I'll see you guys next time.